Hey folks, hope you're all having a great day. Uh, Welcome to the 123rd episode of YFTT, Tech Talks for Engineers by Engineers. Today, we have with us Jim Nicely, who's a YugabyteDB expert on many things. This is his, I think, second YFTT talk. He has already done one talk on YugabyteDB tips. He runs that website. Today, he's going to talk about the significance of co-located tables, when to use them, and how to use them. Over to you, Jim.
Thanks, Bram. Hi, everyone. Yeah, I'm Jim Nicely. I usually attend these every week, so it's kind of different being on the other side
Yeah.
presenting. But um, anyway, so yeah,
Jim is
today
one of the most active part of the audience. So
I always tell my customers about these great talks. So today we're going to talk about co-located tables. We'll get started really quick here. So uh, most people are probably familiar with what a tablet is in Yugabyte, but I'll cover that real quickly. So a tablet is basically just a piece of a table, right? It's a group of the rows from a table. And the term tablet originates from an ancient writing surface. So I'm sure you've seen like tablets with, back in, BC times, people writing on these clay or stone slabs.
like the Ten Commandments.
Yeah, exactly. So that's where tablets, that's where we got the name from. So tablets are also known as shards. And then Yugabyte has, one of the key features of Yugabyte is something called auto sharding, and that's how Yugabyte distributes data across multiple nodes. That's how it distributes these shards. And then we support two different sharding types, hash and range. And these are on the Postgres side. If you're using the Cassandra side, we support hash partitioning. And then over here on the right, just an example of what it looks like. This is a hash partitioning. Again, it's just a group of rows, or there's a hash function applied, and then the rows are pushed off to different tablets. Here's three tablets. These are the leaders. And then down here is range sharding, which is a little different. Still a group of rows, but it's grouped a little bit differently, pushed to these tablets.
So basically, in
Uh,
range sharding, the contiguous keys typically get located together in the same tablet.
yeah. So what is table colocation? It should be tablet. Oh, that is table colocation. Yeah. So this is something that's supported in YSQL only, not in YCQL. But what it is like closely related data can be grouped together in a single tablet. So as opposed to having multiple tablets for multiple objects, now we're going to have a single tablet for all of your tables and all of your indexes. And what this gives you is low latency read and writes, and high performance for accessing the data. And the reason you get that is because like network hops are eliminated, especially on things like joins. That no longer happens because the data is all located together. And also gets sort of storage overhead because each tablet has overhead associated with it. So by reducing the number of tablets, you're reducing this overhead. Um, and then, the good point is like even though you only have a single tablet, it's still replicated. It's still using our raft protocol to replicate your data. So if you have an RF3, a single tablet will be replicated twice. So we still maintain the RF factor for you. So yeah, again, the benefits of colocation is sometimes greatly improved in performance, and we'll see a little bit of that in a demo. Um, and we get this because again, we only have a single tablet versus one or more tablets per relation, and then faster access to data. Again, it's because of that internode communication and data shuffling doesn't happen. Joins are much quicker, as we're going to see. It's because of this. The network reads are much lower. And just basically down here just shows you could have 1,000 tables, but it's only going to go to one tablet or one shard.
The storage, I just want to mention that overhead is not greatly reduced, but that is not the reason why we implemented the co-location. It's for the second reason, faster access to data in reducing the number of hops.
Correct. Thanks, Prem. Yeah. So we'll go through. There's like three main use cases for co-location. The first one being small data sets needing HA or geodistribution. And this is typically a database of size 50 gigabytes. Um, and these time databases typically have a large number of tables and indexes. So normally Yugabyte would be creating multiple tablets for these tables and indexes, but with colocation, this will be reduced to a single tablet. And it's great, again, this is for HA because we're going to be replicating that tablet for you. And it's also good for geographic data distribution. And we'll see later on how you can control the placement of this tablet using table spaces. But this isn't like if you're expecting your data set to grow or the number of IOPS, to increase dramatically, this might not be a good solution. But typically for a small, like a Postgres database that you're migrating to Yugabyte, this is a great option. And then use case number two is you might have large data sets, meaning that if you have a few large tables but many small tables, and we see this a lot with IoT use cases where there could be a couple of event tables that are storing all of the events as they're being streamed in. So those tables can be, pretty massive. And for those guys, you would want to, you don't want to co-locate those. You're going to want those to be distributed as a typical table would be. And that's one of the options you can do is within a co-located database, you have the option to opt out of co-location. So by default, tables, if you create a co-located database, they will be co-located, but you can create a table and opt out of co-location. So it uses the normal hash and hash partitioning so that it's more distributed. But for the smaller tables, they're going to be co-located. Like the smaller tables are typically lookup tables, right? If you have an event table, you're going to have many little foreign keyed tables that you can group all together in co-location. And then the third use case is we're seeing a lot more, and this is like multi-tenancy kind of use cases where you could have multiple clients in a single database. I'm sorry, in a single cluster of Yugabyte, but you could have multiple databases, one per client. And this is also true of microservice kind of oriented architecture, where each microservice needs its own database. But I see a lot, like I said, multi-tenant, like SaaS services, where like there's an application that might have 15 to 20 tables. So when you create multiple databases for these customers, you're just repeating those 15 tables over and over again, and each of those tables and indexes have tablets. This is just creating it could potentially, if you have 1,000 databases or 1,000 tenants, there's a lot of overhead with those um, tablets. So if you co-locate them in a data each database, it's only one tablet for all of your tables. So you can have 1,000 tenants, right? But I only have 1,000 tablets, which is
Awesome.
kind of cool. Yeah,
That's a very great use case.
yeah. Actually, working with a customer right now to help with that. So, how do you enable co-location? It can be enabled firstly at the cluster level. There's a G flag called YSQL colocate database by default. It's false by out of the box, but you can set it to true, and every database that you create from from that point forward will be co-located. And this has to be set on the YB master and the YBT server. And note that if you're using YBM or if you're using Aon YugabyteDB, the managed service, it's not, you can't do it the co-location at the cluster level. It has to be done at the database level. And the next level, again, is the database level. So if you don't have it set at the cluster level, you can, for each database you can create, you can specify co-location true or false. And by default, it's false. So basically, you just say, if you want it to be co-located, you say with true.
So once a database is created with collocation equal to true, all the tables that are created inside that database will be collocated, correct, Jim?
Yeah, by default, unless you
By
opt
default.
out. Yeah. And here's, we're at the table level. So it's a table level, you say with and this is opting out. if you're within a co-located database, but if you don't have a co-located database, you can't create a co-located table. So first of all, you have to have a co-located database, and then once you have a co-located database, creating a table without specifying a co-location, it'll be true. So they will be co-located. But to opt out, like this is that use case we're talking about, the bigger tables, you would want to do co-location false. So whatever the primary key is, or the partition key is, how it'll be hashed. It was just like a normal table would be without co-location. And then later on, once you might forget if you have a database co-located or not. So there's a nice function called YB is database co-located. It just returns true or false for the current database you're connected to. And then you can also check if a table is co-located or not. Just there's a \d in YSQL sh our CLI. Just you can describe the table and it'll show if it's co-located or not. It also shows if the indexes are co-located, which they will be if your table is co-located. And then, yeah, oh, there's the other option. There's another function that we have called YB table properties. It's a table function that returns a couple columns, and one of the columns is called is located. So you just pass in the table name, and it's another option to see if a table is co-located. So now we can start our demo.
Oh, we are already at the demo right now.
Yeah.
So we are moving fast.
Okay. Okay. Can you guys see this?
Yes, I had it.
Okay.
Yes, you are sharing.
Is there any questions we need to cover?
No, none right now.
Okay. So I just wanted to let everyone know I'm using version 223.1. This is the latest version. And the reason I'm using this version is because I'm going to show you table spaces, which is a newer feature that will be out in 223 and also in 224.2. So the cluster.
Take 1 minute. So table spaces is an existing feature. Is that we are supporting table spaces for co-located tables?
Yeah. Yes. Yeah. Thanks for.
That's the
Yeah.
new feature.
Yeah. Table spaces are definitely supported, but not with co-location, but they will be. So, which is awesome feature. So real quickly, I just wanted to show you, I have a 3-node cluster. This is up in AWS. These are the regions and zones. And, I'm just using this YB server's built-in function in Yugabyte to get the server information. And then I'm just using this iNet client to say, oh, this is the node I'm connected to. So FYI, I'm running my commands from US East 1.
Oh, nice. This is cool. I didn't know we could do this.
Okay, so first let's create ourselves a co-located database. And again, we're saying with colocation equal true. And then we're going to connect to the database. And then we're going to create some tables.
Could you also show /d?
Sure.
That, yeah.
Yeah, so let's look at, so notice here I did colocation true. You don't have to do that. I did this for emphasis, but if I don't have to specify this because we're already in the colocated database. Yeah, but here I'm opting out with colocation equals false. So if I did a \d on this guy, you'll see colocation is true. But if I do this same on 2,
Opt out.
oh, I didn't. That's yeah. There we go. Thank you. Yeah. So here the colocation doesn't show up. Okay. So now let me clear this so we can get back up top. So now what I'm doing is I'm generating. I like to do a lot of SQL to generate SQL. So that I later on, if you get the presentation, you can look at the code more in depth. But basically, all I'm doing is using this table I'm using YB table properties and PG tables. So I just want to pull out information about the tables I've created. And this is basically what this will do. So I just wanted to show you that here's my 4 tables, and there's this YB table properties function, this is the information that it contains, right? So it's going to show me the number of tablets and whether it's collocated or not, and then the colocation ID. So it's so you, as you remember that when the opt-in ones are collocated, so they only have one tablet, whereas the opt-out ones have three tablets because that's the default. Whenever you have automatic tablet splitting turned on, you'll get one tablet per node, and I have three nodes, which is why I have three tablets. And then again, I remember these guys are collocated, these aren't. And then if you're collocated, you get a colocation ID. And this is a unique number per relation of how Yugabyte knows within the tablet where to get the information for the particular table. And you can we'll see a little bit later on, I can actually specify the colocation. If you don't, Yugabyte just generates it for you. Okay, let's continue. So what I did here is I'm querying that there's a table called YB local tablets. That's a newer feature. This is in 2024. I use this all the time now. Before you used to have to get metadata outside of YSQL, but now you can do it internally. So I can get I get the table name and the table ID, and this a little get a little smaller. The tablet ID. So this is super helpful, right? So
Yeah.
before, like if you have YBA, you can get that information really easily. But if you're using open source now, you can just get it right within. And I need that information because let's do. Oh, I'm gonna show you this too. Let's skip that. Okay. Go here. So what I want to do is I want to see. This guy. So again, I'm generating SQL. I'm generating SQL to run a YB admin command. So, and I'll do this here. So what I wanted to do was I wanted to see the leader node for my tablet. So I have one tablet for my table, my this the for the collocated tablet. This is how you see the leader. I'm using YB admin to do that, using list tablets and then just passing in the table ID and then I do some Linux stuff here to pull out just the leader node. So what I kind of wanted to show you was what Yugabyte did was it created this tablet on node 54. Oh, actually that's good. Okay, so it created it locally. Sometimes you have to be careful. It might create it over here, which could give you bad performance depending on where your application is. But what we're going to see later is we can control where the placement is using a table space. But in this case, we got lucky. It put it on 54, which is the node that we're on, which is what we wanted. So sometimes it puts it out on 124, then we got to move it manually. So this time we got lucky. So we can skip this step. So let's do some testing. I'm going to turn timing on. Clear the screen. Insert some data. This is a small data set. And right away, we'll see, so the opt-in ones. Okay. Finish, yeah, 1, 2, 3, 4, okay. And then let's do. Okay. I'm going to run a couple select statements here. So looking at, so here's the opt-out ones. The execution time here is almost 300 milliseconds, but the co-located tables are 66 milliseconds. So
wow. So
basically, you can see the performance bump on a simple query like that. It's just a point lookup. Here's a little. Let's get if you do even a little more. Oops, I missed the E. Sorry.
So this is the difference primarily is because we are looking up multiple keys, correct?
Yeah,
Jim?
yeah. So this is an index lookup. So I created the. Oh, did I create the? Did we do? Oh, we didn't do the index. Let's do that. Sorry, I skipped over a whole step. So unfortunately, the creating the indexes takes 52 seconds. But what we'll see, so even without the index, so this is looking up um,
Four
on.
keys.
Yeah,
So in a distributed table, you could end up looking up multiple nodes,
exactly.
but
That's what
on
I
a, yeah,
tried to do
exactly.
here.
Sure.
Yeah. So as soon as this finishes, we'll see that. Um, I'll let that continue. And the reason it's taking so long is, remember, I have a node out in the west.
Oh, still it's taking, you had only 10,000 rows.
100,000.
Oh, 100,000. Okay. All right.
Yeah.
Sorry.
Okay. So this takes about 20. So the interesting thing here is it's a lot faster to create an index on colocation than it is about somewhat twice as fast.
This is very cool, actually, the way the numbers are dying out.
Okay. So let's now try running this. Now we have an index on Y. So the opt-out guy took 3.1 seconds, almost 3.2 seconds, whereas the opt-in was only 75 milliseconds. So that's pretty dramatic. And this is using. I specifically did partitions that are across this. This is fully distributed, whereas this one isn't, right? Because this is local. It's not localized because we co-located it.
Can we see the dist command? Maybe we can show the number of requests.
Yeah, yeah,
There was table index read, storage read request was 60.
yeah. I think the difference is we'll see. Okay, then I'll run it on the other guy here. I'm just gonna. I'll add it here. This. Yeah,
How do we? So index requests were 40, total number of storage requests were only 40.
yeah. So
Storage
it's
read requests were 40 compared to 80 previously, so, or 60
60.
previously.
Yeah.
Yeah,
I think the biggest, I think the issue is it's reading from the West Coast too. So
yeah. So that to 40 requests to the same node versus 60 requests across nodes.
right,
Okay.
and then the we'll do a join now. So up this first query, this guy here, I'm joining. These guys are the opt-outs, and doing a join. The query time is 3.4, and then down here it's much faster. Yeah,
Wow.
same query,
Wow.
which is I think kind of cool. And also, so that's kind of the gist of query stuff. But we can also materialized views are supported. So I'll just quickly show you the difference between. I'll create a. You can create a materialized view that is um, not co-located and one that is co-located. Just the same thing with colocation equals false, with colocation equals true. And then when we query them, you see that the opt-out guy is 1.5 milliseconds versus 44.
Pretty
So
cool.
yeah, so being able
That's
to choose materialized views, whether you collocate them or not collocate them, is kind of neat. Okay, so let's do I'm going to show you the table space example. And this is new to
yeah.
2023.
We have about 6 minutes.
Ooh, okay, I'll speed up. Again, here's just a reminder of the nodes. So what I'm doing is I'm creating a table space. I call it my preferred region TS, and what I'm doing is you'll see each of my zones here, and then I'm adding a leader preference. So I'm saying leader preference 1, 2, and 3. Here I'm saying the leader preference is US East 1A. So this will now it'll guarantee you that all of the tablets created, if I specify my this um, table space when I create the table, will go to. I'll create another database. Note that table spaces are public; they're outside of the database, so I could use this same table space in all of my databases. And when I create this, I specified over here my preferred region. Uh, speed up. Okay,
But
go ahead.
but the previous one was created in US East one, right?
We
Right.
got lucky.
We got
Yeah.
lucky there. Okay, all right. So now we are forcing it to be on US East one.
Yeah. So that like what's funny is like every test I've been doing, it always puts it in US West. But now we're doing a demo. I put it. So anyway, yeah. So again, I'm right here. So we'll see the leader is 54. So yeah. So it this just guarantees you, and it's good for like um, if you like that multi-tenancy database situation where I have a different database per customer. That'll give you the ability to put the tables for a particular database in a on a particular vault domain, right, to wherever you want it to be. Um,
Well,
so maybe we have time for
yeah, go ahead. Yeah, we have time.
okay. Oh, I made this cursor so big I can't move. Oh, here we go. Okay, so I'm gonna do an X cluster demo real fast, and I'm gonna connect to a different server to do this. Okay. So XCluster is supported for co-located tables, and let's just do a quick demo. So up top here, I have
That's from 223, right?
no, it's available. This is 224 I'm using right here.
Oh, 2024. Okay,
Mhm.
2024 and okay, and Alfred.
Uh, so I'm creating a database. Let's create two table. I'll create one table and one index. So note here, I'm creating this table called test. I say colocation equals true. I don't need that because I'm in a collocated database, but I'm specifying a colocation ID here. And the reason this is important, this colocation ID has to be the same on both sides of the X cluster. Otherwise, it won't work. So here if you guys can guess where I got this number, that's a bonus point. But so normally you don't have to do this because if you're doing X cluster, like what you would be doing a backup and restore. So if it did a restore on the target side, it'll bring over these colocation IDs. But for this demo, I have to do this because I'm not going to do a restore. I'm going to actually create the table on the other side manually. So that's why I'm specifying the colocation ID. So I'm creating the same database name, same table, test, same indexes. Then each object has to have a unique colocation ID. So you'll note that the table and the index have different.
Hey, wait. So the table and the index, the co-location IDs seem to be different, or is it
They
because of
are.
the high? They are okay.
Yeah, every object has to have a different colocation ID.
Okay.
Okay, so let's go back up to. I'm using this YB local tablets to get the table ID because remember when you're setting up X cluster, you're going to be passing in that ID. So again, I'm generating SQL. I have SQL to generate SQL. So I just generated this command so I can run it. I'm running a YB admin command to set up replication. This is the source database. This is the target. This is just some random name you pick for your replication. Here's the YB admin command. But then I need to put this table ID in my command down here. And it should say, okay, replication set up successfully. And then I come back up top. I just insert some data into the table. And hopefully it got copied over to here. Yeah, 1,000 rows
Yeah,
are copied.
awesome, man.
Sweet.
Awesome.
So the one thing to keep in mind is if your XCLA is not supported yet in YBA, there's not a way to do the colocation ID piece. But that I think that's a feature coming. But for if you do want to use this, you'd have to do a command line using YB admin. So just
Cool.
something to keep in mind. But it's not that hard because there's only one tablet. So it's not like you're not specifying 100 different tablets, right? Like
All
so.
right. Very cool.
But
Is
that's it.
that the?
Yeah.
That's it. Pretty cool. Yeah, we are almost at time. So, folks, so this is, I say, colocation is essential an anti-pattern for distributed systems, but it has its own niche set of use cases, especially lookup tables, reference tables. But you have to remember it doesn't spread across multiple machines and it doesn't scale. But so that's why you have to make sure that you pick the small tables, and then as Jim said, the total data side, if it's better if it is less than 50 gigabytes on
Yeah.
the set of tables.
That's a good point. Like you can't Yugabyte allows you to pre-split tables. You can't do that with these guys, right? So you can't say create table with colocation equal true, split into 5 tablets. It won't let you do that. Also, automatic tablet splitting isn't supported.
Yeah,
So whatever you get when you start with is so that's why the use case for a small table gets bigger and bigger and bigger. You're going to have to if that happens and you have to convert it to a regular table, but there's no command to do that. You'd have to create a new table and then insert all of the data so that there's a potential downtime then when you're switching over from the old table to the new table. So
yeah. So because also I forgot one thing. I think because all the when you put multiple tables in the same tablet with colocation, when you actually do a DDL operation on one table, it could block the DML operations on another table because it's a tablet level lock, and these are all the tables. All the tables are in the same tablet. So
exactly,
That's one thing that you have to remember.
yeah, that's very true. Yes.
Very cool demo, Jim. Thank you. And then final words.
Yeah, like this is a cool feature. It definitely has its like you said niche. Um, you know, but if you have a small Postgres application, this is a great. It has like a lot of tables and a lot of joins, and you're worried about the joins, especially if it's a small data set. You definitely don't want to be doing those joins across a distributed cluster. Being able to put that in one tablet, all those tables, getting rid of all of the network hop is just it's a game changer for these smaller data sets.
So typically, when we create indexes and on tables, the index is completely distributed differently than the table data. But when you have co-located tables and indexes, both
They're
the
all the
index
same.
and
Yeah,
are on the same machine, same tablet. So
exactly. Yeah.
that's a huge performance difference.
Right. Yep.
So I don't have any questions. All right,
That's
that's
because
it.
we were so thorough. There's no question.
Jim, nicely done, nicely done. All right, so all right, folks, have a great day. Final words, Jim. We can close it out.
Thanks everyone. Hopefully I can do a couple more of these. And, I enjoy this a lot. Thank you.
Yeah, bye, folks.